Okay. Okay. Dr. Bernard, I'm just making, you can start your speech, Dr. Bernard.
Oh, so I become the first one, right?
Yeah, Dr. Snell is not responding to my request.
But I can't share the screen. It's a host disabled person screen
okay.
sharing.
I'll just make you host so you can share your screen. You are the host, Dr. Bernard.
Okay. So share my screen. So you can see the slide is moving.
Yeah, I can see it. It's okay with me.
Okay. Okay. So we wait for 2 o'clock or shall we start?
Dr. Bernard?
Yeah.
Yeah. Okay.
So I can start now, right?
Yeah, it's okay. It's okay. I can see, I can hear you properly.
Okay. So start now.
Yeah,
Okay.
start. Yeah. 1 minute. Could you wait 1 minute till we can start at nine? So more people could join.
Okay, can.
Yeah, just 1 minute.
Okay, sure.
Yeah, Dr. Bernard, it's 9 o'clock. You can start your presentation.
Okay. Yeah. Thank you, Mr. Chairman. And good morning to everyone. Okay, so now the time in Malaysia is about 2 p.m. So it's afternoon in Malaysia. So thank you for coming to my keynote speech on the indoor air quality and ventilation, a key to creating infection-resilient buildings. Okay, so I'm Bernard Saw from University Tunku Abdul Rahman, okay, Malaysia. So this is my presentation outline. First one, we go to the brief introduction to this IAQ, indoor air quality. Then we'll talk about cause and symptoms of low IAQ. Then we'll briefly discuss the transmission route of this SARS-CoV-2. Then we go to building ventilation, airborne contamination removal. Then we move on to air balancing and also UVC applications. Okay, so what is so-called this IAQ? So IAQ is referred to the indoor air quality. So it's the air quality within or around the buildings and the structure, especially related to the health and comfort of the building occupants. Okay, so it's very important for us to understanding and controlling the common pollutant present in the indoor and to reduce the risk of indoor health concerns. Okay, so the health effect from indoor air pollutant may be experienced soon after exposed or the possible year or later. Okay. So this is a typical example if a low IQ which happened in my country. So you have a still indoor air, then you add this excessive humidity, then you have found that the mold and the odor will grow in the building. Okay, so subsequently you bring to effect that you feel headache, nausea, then you have this respiratory issue, fatigue, and subsequently some people may experience this so-called sick builder syndrome. Okay, so means that you don't have any health issue, right? But you stay for a long time in certain place in the building. Then after that, you develop the health issue. Okay, that we call sick builder syndrome. Okay, why this IQ is so important? As you know that about 90%, for the people, they spend about 90% of the time in indoor. Okay, so and in indoor, humans exposed to the air pollution about 2 to 5 times more than the outdoor exposure. Okay, so it's very important for us to have a good indoor air quality to improve our workplace productivity and reduce the absenteeism of worker and upgrading the investment. Okay, so indoor air quality is also a correlation actually between the low productivity and dissatisfaction between the worker. Okay, so there's a real cause of this low IQ, which is lack of outdoor air supply in the air conditioner room, overcrowding, smoking, the lack of infiltration and off-gassing for the material and mechanical equipment, which is typically happen when you have a new furniture in your office or in your home. Okay, and improper control the temperature, either it's very cold, too cold, or too hot, then you lost the control of this humidity, which subsequently lead to the growth of a fungus and also mold. Okay, and inadequate filter level and placement. Okay, this is a typical, right, low IQ that we doing the building inspection, right, that we have found this broken duct, improper duct installation, like low building ventilation, indoor overcrowding, and perfume spraying, human behavior, and indoor poor filtration system. Okay, so there are various types of this airborne contamination. First one is microorganism, particular contaminants, gaseous contaminant, and vaporous contaminant. So today our highlight is on this microorganism. So what is this microorganism? They are usually the virus, bacteria, and fungi. Okay, so various type of these viruses, you have the influenza, coronavirus, SARS-CoV-2, then common cold virus, and mumps. So bacteria have this tuberculosis, we call it TB bacteria, or pneumonia plaque. Okay, fungi usually result in the mold on the wall, ceiling, and the attic of the house. So we briefly go through this SARS-CoV-2. I think it's very familiar to all of us when you're talking about this COVID-19. So COVID-19 is mainly caused by this SARS-CoV-2 virus. Okay, so you stay for 14 days and more in the body, become before the symptom appear. Okay, so the diameter is very small, is more tiny than the hair, which is about 50 to 200 nanometer. So as up to the April, we have about 700 million cases and 7 million deaths reported. But however, some of countries are slow going into the post-pandemic and they stop reporting. Okay, but nowadays we still heard there are many more cases, and those are the different variants caused by the Omicron. As you know that the three famous transmission routes for this SARS-CoV-2, one is through this aerosol inhalation, droplet spray and deposition. Then you have a surface touch. So you have this short range transmission and versus this long range. So short range mainly by the close contact, okay, and the long range by the distant airborne, okay, and the distant formite. So in this SARS-CoV-2, what we learned, right? We got see these four basic type of observation where you have the cold dominance caused by inhalation inject. Then most infection is occur in the indoor, which is caused by the poor ventilation, and outdoor infection is less, which is due to good ventilation at the outdoor, and the long range occur occasionally, which is due to insufficient ventilation. So how we encounter this is by wearing the mask that can help us block this aspergillus and have some filtration. Okay, so where the area we have a high infection rate with a heavy activity like the singing in the choir or something, that you need a very good ventilation venue or setup. Okay, as compared, why this the low risk at the outdoor, right? Because as we see that this is normalized virus concentration at the outdoor, at the distance, right, 0.75 meter, the outdoor is about a virus concentration about 0.083. So if you happen indoor with a very poor ventilation, you have a 1 liter per second, the virus concentration is about 0.129. If you manage to dilute or to provide more outdoor air into your building, then you can simulate the similar condition indoor with respect to the outdoor. Okay, so if you can provide a very good ventilation, then the risk, right, the risk, inhalation risk is getting lower. Okay, so this is estimation that we done in one of the hospital in Malaysia. So this is one of the air conditioner room without any fresh air supply. So once the virus is exhaled out by the patient, is still inside the room without getting out anywhere. So whatever the nurses or doctor came in into the ward, so without wearing mask, then they'll get infected by the virus. Okay. In Malaysia, we are for all the building, we are using this uniform building by law or refer building by law. So to construct building, and the ventilation is guided by the ASHRAE standard. And some people say that why this outdoor is so important, why not you using 100% of the outdoor air pumping into the building? Okay, so there are two main reasons why we are not using 100% outdoor, which is due to the heating and cooling equipment sizing will be getting larger, and also the high energy consumption. Okay, so the electricity bill will become the boom. So in the typical setup for this air conditioner, then you see that there is a fresh air supply. Okay, so fresh air supply to this air conditioner and supply to the building. So the higher this ACH or air change rate, then the less time required to remove a contaminant in the indoor. Okay, so when you're doing the building inspection, then you can see that why they have a poor ventilation. The reason is they have a damper is closed, which is the fresh air damper is closed. Then improper connection of this ducting, that's how this ducting tear off, or the motorized damper is malfunction, and thus accumulation and the twisted duct. These are the common things that you can find in the building where they don't have a good IAQ. Okay, so it's very important for us to do the balancing, okay, balancing of the air conditioning, okay, and also the ACMV. Okay, when to have it then for new construction site, and when doing renovation and rebalancing and equipment change, then the building have a comfort issue. Okay, so next one move on to UVC. So UVC is not that strange for us, right? Some of them using this UVC 254 to deactivate the virus. I not say kill, is more appropriate term to say is to deactivate the virus. So you'll be using in the in-duct air disinfection, and also the upper air, and also the in-duct surface disinfection, or the use of some portable room decontamination. Okay, so this is a typical upper room UVGI that we install in the office. Then they can provide additional air change unit to the building. Okay, so minimum height should be 2.5 meter. Okay, and the UVGI is installed about 2.1 meter, which is above the head of the human. Okay, so the nice exposure for UVC 254 is about 0.2 microwatt per centimeter square for 8 hours. So another thing we look is this UVC, far UVC 222 nanometer, which is promoted during this COVID time. Okay, so this UVGI 22 nanometer is produced by the krypton chloride assignment lamp. Okay, so a 12-watt lamp will produce 0.05 ppm of ozone in 30 meters cube of room in 267 hours. So it's very important that if you install this UVC 22 nanometer, you need to ensure that you don't have a sufficient outdoor air supply, else you will have this ozone issue. Okay, so through the simulation and also experiment, it found that it's important to have this UVC lamp installed close to the air conditioner outlet, okay, where you can have the higher reduction of this bacteria. Okay, so another thing is the exposure duration is also very important to have a higher log reduction, okay, for different type of viruses and also bacteria. Okay, this is the equivalent air change rate for different type of bacteria. Okay, thank you. Yeah, any question? Yeah, thank you. Any question from the audience? So if you have any question, you can always contact me. Okay, this is my email address, saulh@utah.edu.my.
Thank you, Professor, very much. It was very interesting presentation. And I think the host is muted. Please open your mic.
Okay, Doctor, we will go to Dr. Snehal. Dr. Snehal?
Yeah,
Yeah, so,
Snehal is there. So just give us 2 minutes.
okay, I'm just make her the host.
Okay, sure. Yeah.
Okay, 1 minute.
Join it.
Dr. Snell, you are the host.
Yeah, you've made me as a host, right? Archana
Yes,
Bagil,
yes.
I made Snehal as a host, don't worry.
Yeah.
Dear chair of session, please, I have a question for the first presenter, if it's possible.
Let's Dr. Snehal do the
late.
presentation. And yeah, it's okay. But after that, we have 10 minutes for the questions.
Okay, thank you so much.
Is there any problem, Dr. Snehal?
Can you make Dr. Snehal as a host?
Yeah, she's the host.
Okay. Snehal is the host, right?
Yeah, yeah.
Okay.
The participant screen sharing. I need to have the participant sheet screen sharing.
Okay. Yeah, she's the host. Yeah. You can share your screen right now.
Is that
We can see.
done?
Yeah, we
Hello?
can see your screen.
Okay. Shall I get going?
Yeah.
Okay. Good morning, everybody. It's a pleasure to be part of this ICCA plus U 7th International Symposium. Thank you, Alanya University, for hosting it. And thank you to Anant National University for the participation. I will now share my thoughts with you, and okay. Is my screen visible?
Yeah, it's fine.
Great, great.
It's
Thank
fine.
you.
Yeah.
So I'm going to discuss with you today three. Sorry, I am extremely sorry. Can this be minimized, please? I don't want to see this. Can this be minimized?
Yeah.
It's ahead. Yes. We just move it.
It's fine. If you
Great.
go, yeah, it's
So I
fine.
will be talking about three aspects of my work. One is academic thought, academic work, and practice as an academic. And I will begin with the ideas that kind of contribute to my work and practice. So I look at architecture as an infinite triad, which is looking at temporal triad, which is past, present, which kind of feeds into the future. And we've been going through this cycle forever and ever. And if I look at the idea of what is the scenario of architectural practice today, we realize that we look for a lot of clearances, and a lot of these clearances come from various different consultants, which are looking at greater than average speeds, potential for events. So they're creating these future scenarios for us. And all of these are actually clearances that we need to get for our work. And if we look at the predicament that we have is that there is climate, energy, seismic, material, all of these agencies predicting futures and creating a body of code that architecture today answers. So architecture sometimes has become in a servicing position rather than looking at it as a situation which depicts future like we used to do in the past, where we actually created the future for everybody. So today we have a situation where past exists and future is dictating what the present should be. And the model of the future is compelling our action in the present, as I showed. So with this thought that I have, I realize that these models can't be the same and we cannot be functioning with this. So in my academic journey, as my work in design, what I do is I create a studio which looks at imagined scenarios, which is looking at the development around Ahmedabad, around this little lake, and we are looking at the idea as to how the scenarios can be built from within architecture, and can we have imaginations that will look at architecture and create new codes with the idea of new developments and new thoughts which emerge from architecture. So the student projects questioned the fact that today we do not build new water structures as architecture, we only build them as service. So can we create a new architecture that looks at building up of new water reservoirs, which are actually public places? So that was one kind of one stream of questioning that happened. The second stream of questioning that the student work took ahead was creating a new public ground, looking at disparate little individual projects and little individual houses, and can there be a new public ground which kind of sits on top of these private terraces? And his imagination took hold of an absolutely new, almost a parasitic development that occurs on top of individual terraces. The third one was looking at the current urban ground which the roads have taken over. And she was wondering that can we actually pedestrianize paths, and when we have projects which are public projects on three ends, can we actually create a node to agglomerate an idea of a public place, and can that become the new imagination for this village? The student was looking at urban farming as a link between urban and rural. He was looking at the idea that can urban farming continue our engagement with nature and continue our engagement with farming, which we are actually usurping and creating new developments. So his idea was, can we create nodes and typologies of urban farming in the newer developments of such different villages around the city? She was looking at an embracive idea of the working of the animals and creating them as part of our continued engagement with urbanizing, not see them as vitiators into our city, but as part of our city. So she was trying to look at an equitable urban scenario, and she was looking at the idea of animals. And in this village, there was an animal husbandry unit. So she thought, can it become larger, and can it actually become the place where people come, feed the cows, and understand the whole process and create a new place when the city develops, rather than just have it for the roads and have it for human beings, and create an inclusive and architecture for all. We were looking at the idea of reviving the various kinds of septic tanks, and this was a defunct septic tank, and he was wondering that can this become a method of making people aware of the water crisis, and also use this large body in the middle to create a reservoir, and also create other amenities of the village, and when the village gets absorbed in the city, to create a new urban amenities and scenarios, which looks at the septic tank as actually the urban future. So his project looks and creates a monument of collecting water and creating this urban park. The next student looks at ecology as architecture and looks at water systems and networks as public places. And he kind of looks at the idea of current water systems and creates them as monuments and part of the newer development that will probably progress and densify this whole village and create newer marketplaces, more places which are public at the upper level, and create connections as we will take this step forward in the development of the city. And we have such villages all around Ahmedabad, and they're all developing, and such conditions are happening in all the tier 2, tier 3 cities, and that is what is going to be predominantly something that we will have to look at. But if architecture doesn't take a step forward and creates its own future, we will only be answering the future of others' imaginations, other consultants' imagination, because they are also imaginations. They are not reality. They are imaginations of a future. So the idea that we need to really question ourselves towards our practice as well is the fact that, are we really going to just answer the consultants from outside, or create an architecture, and an architecture that questions the current scenarios from within? And with this, I would like to take you to a small journey of a practice. And my practice actually is very small. I'm going to showcase one particular project, just one house, which sits in Ahmedabad. And it sits in the newer part of the Ahmedabad. This area is considered to be the old city of Ahmedabad, which has very traditional houses, while the newer city developed on the western side of the river. Currently, if you look at it, it will be to your left. So there was this old house that was sitting there. And when one was looking at creating a new house, one was trying to figure out that how does one save material and how does one look at this house with the idea of making one's own house, which is developing, but also looking at sustainability as a great factor. So the house came up on the existing plinth as is and used the foundation of the house and created a shed on top of it. So this shed that is there is a ubiquitous shed, which probably one can erect in 7 days. And there's nothing much to it. All the foundation was used as is. So we didn't dig up, we didn't build anything.
Sorry, Dr. Snehal, we have just left with 2 minutes.
Okay, I'll finish it fast, not to worry.
Yeah.
The idea was that we were looking at saving and reusing wood. So this is where wood is collected all over from various old houses. So I collected something like 100 windows. And these are the craftspeople. So the architecture also became a place for craft. These windows were resized. And this is what that shed becomes. So we see how the shed, which is very ubiquitous, becomes something that is not new, not old, but follows system and creates an architecture which questions ourselves and our practice and the material. It looks at the idea of a building with components which are 90% reused, and we are using a whole lot of people to construct it. And no water was used in the construction. Thank you. I'm done.
Thank you, Dr. Snehal. It is on time, 9:30. Sorry, but I think it's we have to go to the sessions now. But still, I think we have a space for one question. If you want to ask one question. Any question for Dr. Snehal?
Yes.
Okay, let's go to the session A. Thank you, Dr. Snehal. Thank you, Dr. Bernard.
Thank you so much.
Thank you. And we will go to the section. Thank you for being here. And we will see you in the session A.